In this video, we will explore a scenario in which a shareable workflow is imported by two different organizations. Each organization will alter the shared workflow with a BPMN tool of their choice to include their own business and security policies. One organization will take a low-regret approach to security automation, resulting in a workflow that will automatically mitigate an indicator of compromise, or IOC, as necessary. The second organization takes a risk-averse approach to security automation that will take an IOC and provide the necessary context in a ticket that will enable an analyst to mitigate the IOC. In the first organization, the shareable workflow is imported using a BPMN tool called Flowable. As you can see, the shareable workflow receives an IP IOC and creates a ticket to track the incident. Next, the IP is checked against a whitelist and a block list maintained by the organization. If the IP is found on either of those lists, the ticket is updated with the appropriate information and closed, ending the workflow. If the IOC is not found on either list, additional enrichment is performed to help determine whether or not the IOC must be mitigated. If the IOC meets the action criteria, the IOC is added to the block list, and an analyst is emailed to determine a course of action to mitigate the IOC. At this point, an organization can add or update tasks within the workflow in order to ensure that it aligns with the organization's business and security policies. For instance, the Conduct Additional Enrichment task in the original shareable workflow can be updated to more specifically query the organization's security tools and check for prevalence of the IOC on their network. Once updated, the BPMN workflow can be exported and saved as an XML file. For the purpose of this demonstration, we've taken the shared workflow, updated it, and exported it as the low-regret workflow seen here. Once exported in an XML file format, the updated workflow can be imported into the CyberSponse SOAR platform. At this point, an analyst must tailor the workflow to use the security tools deployed in this organization's environment. For example, this Create IOC ticket task needs to be tailored to use the ServiceNow ticketing system employed by this particular organization and provide the necessary inputs to fulfill the task of creating a new incident. Again, for the purposes of this demonstration, the import of the low-regret BPMN workflow into CyberSponse has been updated and saved as this low-regret tailored workflow. Notice that many of the green-colored manual tasks from the original workflow have been replaced with tasks that use a specific connector to a third-party tool, which are colored red. Once the necessary updates and testing of the workflows is complete, we now have a local instance of the workflow that is ready to be used. For this demo, we've taken some IP address, IOCs from DHS's Automated Indicator Sharing, or AIS, feed and use them to trigger our shareable workflow. Viewing the execution history of our workflow, we can see that the IOC was received. A ticket was created and various checks were performed. We can also see that the low-regret portion of the workflow was executed and the IOC was automatically blocked at the firewall. The block list was updated and the ServiceNow ticket was automatically closed. We can also log into our Palo Alto firewall and confirm that the IP has been added to the SOAR block IP address group, and it is annotated with a note stating it was added by CyberSponse. checking the PostgreSQL database, we can also see that the IP address has been added to our block list. Finally, looking at our ServiceNow instance, we can see that a ticket was created, annotated with the results of our workflow, and closed. Turning our attention to the second organization, the Shareable workflow is imported using the Camunda BPMN tool. Again, using these BPMN tools, workflows can be altered to align them with the business and security policies specific to the organization. For this demo, we will jump ahead to a workflow that has already been updated using Camunda to take a risk-averse approach to security automation. Since this workflow and the low-regret workflow shown earlier are based on the same shared workflow, there are many similarities, such as creating a ticket for tracking and checking the IOC against a whitelist and block list. However, this risk-averse version of the workflow leaves all the mitigation actions to a human analyst. The updated workflow is exported from the BPMN tool into an XML file format. This second organization uses the Demisto SOAR platform. The IACD team at JHU APL, along with Demisto, created a Python script to convert the XML file into a YAML format. The YAML file is imported into the Demisto platform, where an analyst must tailor the workflow within the SOAR platform to connect it to the security tools within the environment to make a local instance of the workflow that is fully operational. Using the same IOC from the AIS feed in our first example, we execute the risk-averse workflow within Demisto. In this workflow, an email is sent to the analyst with a link to the ServiceNow ticket. The analyst can then go to the workflow and manually see it through to completion, noting if the IOC is a credible threat. Another email is sent to the analyst, noting the threat, and the analyst can then enact mitigations manually. Once finished, one more manual action in the workflow will cause the ticket in ServiceNow to be closed. This concludes our scenario demonstrating one shareable workflow, downloaded machine to machine, to two different commercial off-the-shelf BPMN tools that ingest the shareable workflow XML file. Then, each consumer modifies the shareable workflow, the first tailoring to a low-regret business process, and the second to the risk-averse business process, each producing another machine-to-machine readable file into the consumer's respective SOAR platforms, Cybersponse and Demisto. This demonstration also showed an AIS indicator triggering each of the modified workflows in each of the SOAR platforms, executing two different outcomes based on the consumer's business policies, one blocking the IOC and the other involving an analyst throughout the execution.